Explaining question 7 of homework 7. So we are given that zt is equal to n1t cos omega ct plus theta plus n2t sin omega t plus theta, where theta is uniformly distributed in 0 to 2 pi, and we are given that n1t and n2t are WSS, which is white sands stationary. Also n1t, n2t and theta, all of these are independent. So for the first part, we need to find the expected value of ct. Now since we are given that n1t and n2t are WSS, so expected value of n1t is equal to eta 1 and expected value of n2 is equal to eta 2, which is some constant. And so to find the expected value of zt, we can plug in the value of zt from the given question. And since we are given that n1t, n2t and theta are independent, we can write it as expected value of n1t into expected value of cos omega ct plus theta, and this term can be split into expected value of n2t times expected value of sin omega ct plus theta. And so we can plug in the values of expected value of n1t and expected value of n2t as eta 1 and eta 2. So this equation will become eta 1, and will integrate the find the expected value of cos omega ct plus theta, will integrate it over 0 to 2 pi. And similarly for the second term, it will be eta 2 and then integral of the sin omega t plus theta term over 0 to 2 pi. And we know that the integration over these two terms will be 0, so the final expected value of zt will be 0. Now for the second part, we need to find RZ T1 T2, which is the autocorrelation, and we also need to comment on whether ZT is WSS or not. So RZ T1 T2 can be written as expected value of ZT1 times ZT2. We'll plug in the values of ZT1 and ZT2 from the given equation in the question, and when we expand these terms, it will come out to be 4 terms. So the first term will be expected value of n1 t1 cos omega c t1 plus theta times this term, which is n1 t2 cos omega ct t2 plus theta. Similarly, we'll split it into this term times this term, which is the given term over here, and then n2 t1 sin omega ct plus theta times n2 times n1 t2 cos omega t2 plus theta, which is the third term. And similarly for the first 4 term, we'll multiply these two terms. So now for the first term, n1 t1 n2 n1 t2 can be written as r of n1 tau, where since it is n1 t1 times n1 t2, so we know that it can be written in this form. And for the second term, n1 t1 times n2 t2 can be written as eta 1 and eta 2, because these are constant, as we saw from here. The expected value of these are constant. So this will be the second term. Similarly for the third term, we'll have n2 t1 times n1 t2, which can again be written as the constant values times these two terms in multiplication. And for the last term we have n2 t1 times n2 t2, which can be written as rn2 of tau. Now we'll change this into the integral form. So this can be written as, so the first term will be 1 by 2 rn1 tau times the integral of the whole term from 0 to 2 pi, and we have converted the multiplication of cosine term as the sum in the form of sum of uh, the two terms, and similarly for all the terms we have converted to integral and converted the multiplication form uh, into the addition form. And so finally, after solving all of these terms, we'll get the final term as 1 by 2 n1 tau plus 1 by 2 r n1 tau plus r into tau cosine of omega c tau, and this is equal to rz of tau. So we know that zt is wss, which is asked for the second part, that is ZTWSS. Uh, so that was for the second part. For the third part, we need to find the RZ of 0, and we need to also comment if we need to find RZ of 0 if uh, ZT is WSS. So yeah, so from the second part we know that RZT is equal to this term, so we can plug in the value of t equals to 0, and so we'll get it as RZ0 is equal to 1 by 2 of n10 plus r2 rn2 of 0, and so rn10 can be written as expected value of n1 square t, and rn2 of 0 can be written as expected value of n2 square of t. Yeah, so that is all for the seventh question of homework 7.